What's up everyone? In this video we're going to be going over another type of transformation and we're going to be dealing with reflections. We're going to be reflecting points and figures about the x and y axes and over some other vertical and horizontal lines as well. So a reflection is a mirror image of a point, segment, or figure. Now, to reflect a figure, to create that mirror image, we're going to need a line of reflection or a line of symmetry. So, to think about this in terms of real life, we've all probably had a scenario where we looked at a body of water, kind of like this image here, and we can see that reflection of whatever the scenery is, right? So, the line of reflection in this case is actually going to be the surface of this body of water. So that's our line of reflection. And when we have a line of reflection, what happens is whatever's on one side of the line of reflection is going to be perfectly replicated on the other side of the line of reflection, right? To create that perfect mirror image, we have to create an exact replica on the other side. The orientation of points in a reflection does change. So we've been talking about this with translations. We said that the orientation does not change, right? But in a reflection, the orientation does change. Now, to conceptualize this, I like to think about an ambulance. So if you've ever looked at an ambulance head on, the words ambulance on the front of the vehicle are actually backwards. Now, the reasoning for that is when you look in your rear view mirror, if you're driving or if you're in the front seat, if you look in the rear view mirror, the orientation of those letters actually change when you are looking at that mirror image, right? The reason for that is when you look in your rear view mirror, if you see an ambulance, you'll actually be able to read that word. So to remember this, I like to think of the ambulance example to remember the fact that the orientation of points change when we have a reflection. Now, what doesn't change is size and shape. So the Regents loves to talk about rigid motions and isometries. And when you have a mirror image, it's exactly that. It's a perfect mirror image. So the size of our segment or figures, that's not going to change, which makes a reflection a rigid motion. So let's go over some notation. So reflections have this lowercase r, and then you guys will have this little subscript here. That little subscript is going to be your line of reflection. And it's important to know how to draw these or how to highlight these because you should be doing this every time you have a grid. So when we're reflecting over the x-axis, that is this perfect horizontal line here, right? So that would be our line of reflection. Our basis of creating our mirror image would be that line if we're doing it over the x-axis. Now, if we're doing it over the y-axis, our line of reflection is going to be this vertical line right here. Now, what's different that we might not have seen so much before is this notation of a reflection over the line x equals k. So when you're sketching these lines out, let's say you wanted to reflect over the line x equals 1, right? The thought process here is we want the line that contains points that have an x-coordinate of 1. So I like to start, I'll just plot one point that I know has an x-coordinate of 1. I know this point here has an x-coordinate of 1. And then I'll just start plotting other random points. Like I know this point has an x-coordinate of 1, this point, and then once you have a bunch of points plotted, you can just create your line. So the line x equals 1, it actually tricks your brain a little bit because when you think of of x equaling something, I like to think of the x-axis, right, which is a horizontal line, but it actually flips. So when you have x equals 1 or x equals 2, this is always going to be a vertical line. But if you forget that, you can just do the thought process like I did, right? Find a bunch of points that have an x-coordinate of 1, and then you can just draw your line through those points. Now, the other concept is reflecting over a line of y equals some number. So let's pick y equals -2, right? And again, it's opposite of what you would think. So this line I know is going to be horizontal, but if you forget that, you want to just plot one point that has a y coordinate of -2, and then plot a couple more. I know this coordinate and this coordinate have y coordinates of -2, and then you can go ahead and just connect your points. So if we have a line, y equals -2 looks like that. So let's just dive right into some examples. So in this example, we are finding the image of point P, which is 5, 4, and our line of reflection is the x-axis. So what you should do is always draw over. If you have a colored marker, a colored pen, or a highlighter, highlight your line of reflection. It's going to help you visually see what's happening. Now, if that's our line of reflection, right, that is our basis of creating our mirror image. So we want to measure the distance from P to our line of reflection. So we have 1, 2, 3, 4 units here. And I know to create a perfect mirror image, I also need to be 4 units on the other side. So starting here, we'll go 1, 2, 3, 4. So my point P prime is going to be right here. That is going to give me coordinates of 5, -4. So we have P, 5, 4, and then when we do that reflection over the x-axis, we get coordinates of P prime to be 5, -4. Now, you should be able to notice a pattern between the coordinates of our pre-image and our image, and this is actually a reflection rule. So what the reflection rule is, when you reflect over the x-axis, what's actually going to happen is you just negate your y value. So this makes things a lot quicker. You're not going to have to count on the grid anymore. If you can remember this reflection rule, you can kind of get these questions done a little bit faster. So again, the rule is we had P at 5, 4. So even without a graph, if I had no graph, if I know I'm reflecting over the x-axis, I know that my y value is just going to be negated. So that would be 5, -4. Now, let's do the same point, but now we're going to reflect over the y-axis. So now our line of reflection, when we highlight it, it's going to be this vertical line right here. So graphically, we can create our mirror image just by counting the distance. So from P to our line of reflection, we are 1, 2, 3, 4, 5 units. So we also want to be 5 units on the other side. 1, 2, 3, 4, 5. Now here's P prime. So we go from P, 5, 4, to P prime. And that actually gives us -5, 4. And what you should see here is, again, it's going to be another reflection rule. So when you compare these two coordinates, we can see that our x value is actually the thing that's being negated, and this is a reflection rule. So when we reflect over the y-axis, again, you can do this without a grid. If you remember this rule, you're going to negate your x value. Now, even if you don't have a grid on a question, you can always sketch one out and you can figure this out. So you don't have to remember these reflection rules. They are things that can help you get the questions done a little bit faster. Now, let's reflect a figure over a different line than the axes. So our line of reflection here is going to be the line y equals 3. So if it's y equals, you can actually put it into your calculator if you forget. But the line y equals 3 is the line where all of our points have a y coordinate of 3. Now that's going to be the line that I just drew in or just highlighted right there. Now again, the concept is you want to make sure that all of your points are the same distance away from the line of reflection. So let's do point Q first. Let's do point P first. So point P right now, if we count the distance, that's only 1 unit away. So P prime is going to be right here. So we have points Q, T, and P. Q is 0, 7, T is 4, 3. And then P is 0, 4. So then we're going to be creating Q prime, T prime, and P prime. So again, P is going to be 0, 2, or P prime, sorry, is going to be 0, 2. Now Q prime is a little bit further away. So we have 1, 2, 3, 4. And again, we want to go 1, 2, 3, 4 to create that mirror image. So that's going to be 0, -1. And then for T prime, this is actually interesting because the point T is on our line of reflection. So if you think about it, technically, T is 0 units away from our line of reflection. So if we want to create that mirror image on the other side, we need to go 0 units. So it actually turns out that T is the same point as T prime. So T does not change, or the coordinates of T prime and T are going to be the same since T lies on our line of reflection. So when we connect these points, maybe we'll highlight this in a slightly different color so we can really see it. But when we connect our points, we get a mirror image that looks like that. And again, that line of y equals 3 is the basis. If you think about it in terms of like the mountain image, the line y equals 3 is our lake, and then that's what's helping us create the reflection. Now, last but not least, let's do the same points Q, T, and P, but instead we are reflecting over the line x equals -2. So again, we start by just plotting our line of reflection. Now the line x equals -2 is going to be the line where the points all have coordinates, x coordinates of -2. So that's going to be this line right here. There's x equals -2. And now again, we want to just create our mirror image. So let's do q prime first. Let's measure the distance in a different color. So let's do q prime first. So q is 2 units away from our line of reflection. So we're going to go 2 units here to create q prime. And that's going to be at -4, 7. And then t prime, if we count our units away, we get 1, 2, 3, 4, 5, 6. And we get 1, 2, 3, 4, 5, 6. So t prime is this point right here, and that's -8, 3. And then last but not least, we can do p prime. So p is 2 units away from our line of reflection. So we go 2 units again from our line of reflection. So we get p prime to be located right here, and that is at -4, 4. And we connect our figure. We create a perfect mirror image. Now let's also talk quickly about the orientation portion of reflection. So typically, we usually read coordinates clockwise, right? And it doesn't really matter where you start. But let's say you were naming this first triangle here, right? This was our pre-image here. So when we talk about the points of our pre-image, if we start at Q and we go clockwise, the name would be Q, T, P, right? If you start at Q and you go clockwise, you get Q, then you hit T, then you hit P. However, if we start at Q on our image here, and we go clockwise, we actually get Q prime, P prime, then T prime, right? So in our pre-image, we went Q, T, P, and in our image, we got Q, P, T, right? So that order of the letters, the order of the vertices had changed. So that's usually a dead giveaway that you have a reflection. So just be on the lookout for that. So wrapping this up, remember that a reflection is a mirror image of a figure, and we always need a line of symmetry, and just also know that the orientation of our points is going to change. You don't have to remember these reflection rules though, and just note too that if you don't have a grid, you can always sketch. It doesn't have to be a perfect drawing, but you can always sketch a grid and sketch your points. And as long as you understand the concept that all of your points have to be the same distance away from your line of reflection, then you'll be good to go.